Hello, and welcome to this Smiths Interconnect webinar. My name is Katie, and I will be your Global Spec moderator, and I would like to review a few housekeeping items with you before we begin. Please take a moment to familiarize yourself with the operation of the user interface for today's webinar. The large window with the heading Presentation in the upper left is the primary window for today's webinar. Just to the right of the main presentation window is the Speaker Bio window, with background information on today's presenters. Just below that is the Q&A window. At any time during the presentation, you can enter a question into the box in the lower section of the window and click Submit. Your question will be placed in the queue to address when we get to the Q&A session. At the bottom of your screen, you will see additional buttons to enhance your webinar experience. To see what a particular button does, just place your mouse pointer over it and a tooltip will appear with the description of the button's function. Now I would like to introduce today's presenters. With us today we have Dave Raymond. Dave is a product manager of board-level devices. We also have Tim Meehan. Tim is a technical application engineer of resistive cables and fiber optics and RF components. So today's agenda is as follows. First, we're going to understand qualification standards for the design and development of RF board-level components for space and defense applications. Then we're going to explore some product specifications pertinent to military standards and the application demands for reliability levels and their associated requirements. And then we will address environmental factors, including radiation, shock, and vibration, and contamination. Then we're going to move ourselves into a Q&A session. So before we get started today, there is a polling question I would like to shoot out to all of you. The question we're asking today is, what are you really looking to learn from this webinar? Our options below are high reliability traditional space and defense testing requirements, new space and defense requirements for reduced cost programs, what is available currently on the market for turnkey products and testing solutions, or are you looking to learn about all of the above? Again, the question we're asking all of our attendees is, what are you looking to learn from this webinar today? So if everybody could just start putting in their responses of what they're here for today, that would be great. I'll give you guys a few minutes to enter in your responses. All right, great. It looks like some of you are adding in your response. We appreciate your feedback. Again, what are you really looking to learn from this webinar today? And we've got our 4 items listed below: high reliability of traditional space and defense testing requirements, new space and defense requirements for reduced cost programs. The third option is learning about what's currently available on the market for turnkey products and testing solutions. And then the fourth option we have here for you is all of the above. I will give you another few seconds to submit your answers. All right, and I'm going to push out our results of this right now. So Dave and Tim, if you guys want to talk about our results on this slide here, I'm going to pass things along to you to get us going. Thanks, guys.
Thanks, Katie. We appreciate all of you attending today for this webinar. Looks like everybody wants to learn a little bit about all the above. Well, good news on this is we have a vast experience in space and defense testing requirements. We want to hit on a little bit of all these to show you what is available out on the market and where the market is kind of turning for new space and defense requirements. And we know that recently in the market with COVID and the things that have been happening in the market, that lead time and availability of products is a major concern. So we'll address some of that as we go through the program, through the presentation, and we'll start out with the traditional high reliability space and defense testing requirements, and we will kick that over to Tim Meehan.
Thanks, Dave. I'm going to spend a few minutes discussing the current defense applications. There's recently a movie that came out called Top Gun Maverick, where many of these applications can be seen in that movie. It's a pretty interesting movie as well. Communications, that's going to be your basic radios. It's also going to be identification, friend or foe. There are several different platforms for communications. Electronic warfare, EW, those are for countermeasures used often on the aircraft, attack aircraft. Also other aircraft use them. Even Air Force One has a lot of electronic warfare countermeasures. Then there is ISR, which is intelligence, surveillance, and reconnaissance. That's really used with the electronic warfare and as well for acquiring and processing accurate information in a timely manner. Radar, again, it's used to detect missiles, aircraft, very numerous applications for radar. All of these different applications will have a different reliability. Typically, things that are mobile or easily serviced might not have the same reliability as maybe an aircraft. And even the unmanned aircraft are going to have different reliability as manned aircraft. The manned aircraft obviously is going to require higher reliability. Similarly, with space applications, items that are serviceable, like the ground radar systems, they're going to be in the launch systems. They're easily serviced, so the reliability is not as high as, say, maybe the GEO satellites and the MEO satellites. Whereas now we're seeing a lot of applications for the LEO satellites that the market isn't really requiring the same type of reliability that we've seen in the past. Some of the ground systems, depending on which ground system, they will require different types of reliability, and they vary from low reliability in testing to very high reliability in testing. Here's some traditional MIL testing that we've experienced. The most common one is MIL PRF 55342. It's a specification for resistors. It's also used for our temp variable as well, even though the title says it's for fixed resistors. And it's very common for our board level components. There's also MIL PRF 3933. That one's also common, but not as common as 55342. Most of our customers look for the 55342 for screening, Group A testing, lot qualification, Group B testing. And both of these MIL standards will reference specific standards like MIL Standard 202 or MIL Standard 883. And those standards are for uniform methods for testing our electronic components. They vary from thermal shock, environmental burn, and life test. And where these MIL standards are, they can be found free of charge. Assist Quick Search is one place. Every spec is another place. These are public domain documents that everyone can access. It makes life simpler when we're all working on the same platform, and when our customers and when we develop our own high reliability testing, everybody is aware of what those tests are required. And here's a quick look at MIL Standard 202 and MIL Standard 883. So again, MIL Standard 202, thermal shock, burn-in, life test, solderability, moisture testing, resistance to solvents. Those are just some of the very common tests required for our board level components and what is requested from a lot of our customers. 883 is a little bit larger and more encompassing, where it has other tests like temperature cycling, destructive physical analysis, which is DPA, atmospheric testing, radiographic, X-ray testing, SEM for cross-sectioning. Again, very common in our industry. And that is on the domestic side. These are some examples of some European specifications that we have a lot of experience with as well. They're similar to 55342 and other MIL standards. They also include something called PID. PID is Process Identification Documentation, where often our customers want to know how parts are not only being tested, but how they're being manufactured, almost like a baseline document just make sure everybody is on the same page and expectations are identified. Some other criteria that's similar to the MIL standards is they talk about bridging and shorting and void. Those type of workmanship criteria, which is also identified in the MIL PRF 55342, the European specifications have very similar criteria. And with that, I'm going to turn it over to Dave, where he's going to talk about some space programs.
Thank you, Tim. So as Tim talked about, a lot of the programs in defense and space, all take cues from the satellites that we put up there to communicate with the ground. The geo satellite or geostationary satellite is the most expensive satellites to build and launch. These satellites have an altitude of around 36,000 kilometers. They are fixed in rotation. These satellites are also classified as large satellites. The mass of these satellites can be greater than 500 kilograms. The reliability on these types of satellites are categorized as Class 1, which is the highest level of reliability and requires qualification down to the component level on some of the specs Tim has mentioned before. The customer qualifications on these satellites, as discussed earlier, follows the NASA MIL or ESA spec requirement flow downs. And these are pretty standard in the industry and understood by most manufacturers. These satellites can range from weather satellites, radio, TV network satellites, broadcast satellites, and military satellites. Now, if we look at the MEO satellite constellations, these are medium Earth orbit satellites and have an altitude of about 20,000 kilometers. The rotation on these satellites ranges from 2 to 8 hours, depending on the quantity of the satellites in the orbit. MEO satellites are considered large satellites again, with a mass about the same as the GEO satellite. These MEO satellites' reliability ratings range in Class 1 or Class 2 by category, and they have reliable requirements of qualification that flow down, again, to the component level. These satellites are typically used for space and environmental science, broadband, and GPS functions. You can see some of the examples on the slide. Both the GEO-MEO satellites have very stringent reliability requirements, and a large percentage of the time are strictly followed by the industry standard published specifications as mentioned before. Now when we get into the LEO satellites, which we started seeing probably about a decade ago, these are the newest category of satellites in the satellite programs. They are deployed in a low Earth orbit and range in an altitude from 300 kilometers to 1,500 kilometers. With this category, we have a multitude of different types of satellites, ranging from mini satellites to microsatellites, and finally pico and nano satellites. The mass of these satellites range anywhere from 500 down to 10 kilograms. The LEO satellites can range from reliability ratings from Class 1 to Class 3, depending on the program and application. LEO mini satellites have uses in areas of R&D, remote Earth sensing, and environmental studies, to name a few. Examples of these programs are listed on the slide. LEO satellites, we find that the customer application and cost targets will drive the reliability need. Manufacturers design for aggressive budgets on LEO programs, and price and performance usually wins their contracts. So if we get a little deeper into these types of satellites and the characteristics, as you can see in this slide, the number of satellites vary per orbit they're deployed in and the applications they're used for. GEO satellites have the least number of satellites in the constellation, consisting of 3 that cover the Earth's the surface of the globe. MEO satellites can have anywhere between 8 and 20 satellites in the constellation. In moving over to LEO satellites, these constellations can vary from 40 to over 1,000 satellites per deployment. We start with the GEO satellites. They have the longest lifespan expectancy, with averaging about 20 years, with the cost of launch being the highest in the satellite category. The number of handoffs remains low in this category, while the gateway costs are inexpensive. To only control 3 satellites from the ground is much less cumbersome than a large array. The satellite's latency is high in this category because of the distance traveled by the signal. The reliability expectations are extremely high on the GEO satellite. Failure is considered not an option. Therefore, these products and the reliability are paramount in this category. Customers building these products are expected to pay a premium for the products that are in their bill of materials. For reliability, the products are tested individually, either by the manufacturer or outside test houses. Again, they're tested again in the module after they're assembled. MEO satellite manufacturers have similar expectations on reliability, but we forego some of the test requirements for a lower cost of ownership to capture in the system qualification. So these satellites average a lifespan of about 15 years. The cost of launching these satellites is also reduced because of the shorter distance to orbit. The number of handoffs here remains low, and the gateway costs get more expensive in this category, tracking additional satellites from the ground. But the latency factor on this category is still high because of the distance of the signal travel. Satellite costs in this category traditionally are lower than the GEO category, but the reliability expectations remain high. MEO satellites require a steerable antenna and more complex ground equipment, but have lower latency. Again, this category failure is not an option. Suppliers value high reliability of performance on products in this bill of materials. When we get to the LEO satellites, the manufacturers of these satellites range from traditional startup companies to satellite manufacturers. The LEO satellite programs range from 40 satellites up to greater than 1,000 satellites. Mini satellites, microsatellites, nano and picosatellites all make up this category. The life expectancy depends on the program and the satellite type, and it can range from 1 to 5 years max life. The increased number of satellites of this type drives the cost of the products on the bill of material down, and it's very challenging for a supplier who wants to tap into this market. Launch costs for these satellites are low because of the multiple satellites that can be deployed at once. Gateway costs are most expensive in this category, on account of the number of satellites that need to be tracked in the constellation. Latency concerns are the least in this category for the distance traveled. Reliability aspects of components and sub-assemblies in these satellites are generally very low when it comes to additional testing requirements over a COTS product. The exception in this LEO segment is defense satellites and some commercial satellites, which require reliability based on the program. LEO satellites do not have 24-hour visibility and are normally used for mobile communication and tracking needs. The new space market have cost versus performance sensitivity or a good enough mentality. Failure is an option as spares are deployed for satellite malfunctions. Although failure is not an option, catastrophic failure is not. Many of these satellites do not have redundant capabilities, so large component or system failures could affect throughout the satellite system. Nano and pico satellite systems desire the least performance and cost in this category. COTS or COTS Plus type products will generally be used in this category of the LEO market. So what are manufacturers and customers looking for in the new space and defense market for reliability? We find that specifications and programs are based on each customer or program assign the risk to the design and that what is acceptable for mission success. We also see customers looking for products in the COTS version that have adjacent products with flight heritage, or in other words, with a flight pedigree. Since the size is shrinking and the quantity of satellites are increasing in this space, manufacturers are also looking for partners that can ramp up capacity to meet their needs quickly. This helps customers control cost and delivery schedules, which are paramount in the overall program cost targets and ultimate success of these programs. If reliability needs in the program or application, the manufacturer are looking for low-cost options with only the necessary testing to assure the component's reliability. This comes in when suppliers can automate testing and reduce redundant testing that will not add much additional cost. So again, cost is a huge factor in the LEO programs. Manufacturers are also looking for improved products that have smaller size and weight and cost than traditional high reliability products. With smaller size, customers are looking for increased power to shrink footprints for these smaller satellites. Environmental factors in this class usually require little to no testing. They look for proven products that have shown repeatability over the past. And monolithic products negate any issues with vibration and shock. Having this type of product with no attached leads, top plates, heat sinks, eliminates the possibility of failure due to attachment issues. With a monolithic product, the manufacturer also sees savings in assembly with easy pick-and-place applications. Proven materials can sometimes be a difficult deciding factor on products. This eliminates testing like moisture resistance, resistance to solvents, and other test issues because the testing has been proven on these existing materials and manufacturing products. And the satellites with short life expectancy don't require these additional tests in these areas. COTS products have reliability relatives with space heritage can also be key in the decision-making of products used for LEO satellites. Many products have been qualified regularly to high reliability test plans and can be purchased in the COTS format of non-tested product. In areas where qualification is needed, COTS product can be easily qualified by similarity to ensure some level of reliability that, again, is good enough. Finally, design cycle time and program ramp up is much quicker in this segment of the satellite business. Vendors to these manufacturers need to be able to quote quickly, ramp up quickly for the needs of the manufacturer and to meet the budget and schedule timelines. So these are the most important things when we're looking for new space. It's always lead time and cost, and quality's in there, even though failure is an option. We look at that as kind of something that failure is not an option to come out of us. So on this slide, it just talks about some of the increasing opportunities and risks in the space market, the different subsections in this market, and the anticipated growth CAGRs continue to increase. The market continues to grow at a nice rate, but if we look at the LEO satellites and in the launcher categories, you see the highest growth over the next 5 years. The low Earth orbit satellites are potentially the fastest growing segment providing significant growth opportunities for both manufacturers and suppliers. The need for higher power, throughput, data demands are going to put pressure on the manufacturers to deliver improved performance. The demands of the LEO satellite boom will also be high, with customers and manufacturing needing more cost-effective products, driving towards more reliable standards. We will see in this area demands of qualification, but at a much lower standard. Qualification standards are driven by the manufacturer and the program demands of the satellite, and not necessarily out of a standard published specification. Suppliers of components and subassemblies, in order to be cost competitive, will need to adapt and automate to drive down costs to be able to play in this segment. Also, during the next decade, we'll see GEO satellite demand slow down with the move to more economical constellations with shorter lifespans. With these shorter lifespans, the technology and function of these satellites will improve more rapidly. Risks in the LEO market will be based on manufacturers in customer capacity, funding, and technology. The suppliers who are able to adapt quickly will be successful in this area. Now, I will pass it off to Tim, who will talk about some of the products we address in this future market.
Thank you, Dave. I'm going to speak about some of the product series Smith's board-level components offers, starting with our HM, which is our highest reliability that we have. That is testing strictly per the MIL PRF 55342 with high levels of samples required for lot qualification, Group B testing, Group C testing. It's not common, but some of the GEO programs require this type of HM testing. The most common high reliability testing is our HR. Now that's basically per the MIL 55342 with some customized testing and reduced sample sizes, but provide high levels of reliability. This would be common for GEO market, some defense as well, aircraft, missile systems, those types of things. And we also see our HC, which is a reduced testing that is more common with the LEO market and with some of the launchers and some of the ground-based radar systems. And SPL is a type of testing that is sort of QPL testing. QPL is Qualified Parts List, and those types of testing is sort of based on existing similarity data, where those parts have been tested recently and shown to be proven reliable. That data can be used as similarity data. And the lowest that we have is our COTS level. COTS parts are still tested and they are reliable, but these can be used in the LEO market where we've seen the demand for them. So again, this is our HR series, our most common high reliability. Again, can be used GEO, MEO, not common with the LEO though, and also again with our defense. It starts off after the parts are manufactured, we move into what's called a Group A or a screening test. These are going to be the flight units that are going to be either launched into space or put on an aircraft. We perform 100% visual mechanical. All products are electrically tested to show compliance and serialized at that point. Then we move into a thermal shock, and a thermal shock usually consists of several cycles, usually 5 to 10 cycles of negative 55 degrees C up to 125 degrees C to make sure there's no micro cracks or any imperfections in the components that could cause reliability later on down the road. Again, we'll remeasure these parts, even doing a delta comparison to make sure the parts aren't drifting and that they are stable. From there, we move into an environmental burn-in. This environmental burn-in applies a power at a specific temperature to remove any infant mortality of these components. There's also what's called an allowable loss of parts, and it can't exceed 10%. If it exceeds 10%, that lot is considered suspect. So once it passes that, it's then we go into TCA testing. That's for temperature coefficient of attenuation testing. That's for our temperature variable product. And that pretty much ends the Group A screening, and those will be the flight units that will be flying. Then we'll move into our Group B, which is like a lot qualification test. There's two separate subgroups. The first subgroup consists of a low temperature operation where we test the parts at negative 55 degrees C to make sure they're stable at that environment. And then we'll put them in a high temperature bake to make sure that they'll still be stable at that environment as well. And then depending on which product type, we would do some termination adhesion or solderability. And if the product's wire bondable, we do wire bond testing to ensure there's good adhesion of that gold to the component. The subgroup 2, that has a life test in it, which is a burn-in. This is typically for about 1,000 hours. We take measurements at 200 and 500 hours to make sure there's no problems during that process. So again, when Dave was talking about lead time, and this needs to be considered, 1,000 hours is approximately 6.7 weeks, I believe. Then we move into our Group C testing, and this is very similar as the subgroup 2 testing. We repeat that life test on different samples, but at an elevated temperature. So we have the HC series. The HC series has some benefits where it's still 100% flight test data. It's a good high volume solution. We have capability up to 67 gigahertz, attenuation values from 0 to 20 dB. These are lower cost than the HR series as well. These are a totally passive solution and, again, lower cost of ownership and shorter lead times. So the HC series, the test plan looks very similar to the HR. They almost look identical. There's one large difference in the Group A inspection, whereas we go right from a thermal shock into a bake instead of a burn-in. The burn-in is it's very resource draining, but a lot of customers demand that depending on the application. Again, your GEO, MEO, manned aircraft are going to want the HR series. This HC series is tailored more to LEO markets and unmanned aircraft. And I'm going to turn it over to Dave to talk about some of Smith's heritage.
Thanks, Tim. I appreciate it. So Tim talked a lot about the different types of testing we perform, and the ability to do all this testing under one manufacturing facility is key. We don't sub out the testing. We're able to do all these test plans and test flows internally in the facility, which gives our customer a little ease of supply chain. They don't have to buy a COTS product and send it to a test house to have the products tested. So Smiths has been supplying RF passive components for space and defense missions for over 45 years. We've participated in over 500 military and commercial, scientific, and satellite programs. Our capabilities to assist from design concept through launch include design reviews, qualification, testing, special process documentation, serialized data, weight measurement, and custom packaging. Again, we can also quickly turn a custom test solution to your requirements without any added lead time. We have a long-standing relationship with many of the world's major space companies and defense companies, and continue to grow the relationships with newer space and defense manufacturers. Our mission has always been to design and manufacture high-performance products using the best core technologies of the company while maintaining extreme extremely high reliability levels for long life in military, commercial, and civil satellites. Our space-approved products, in the years of providing them, we have delivered tens of thousands of products to customers ranging from high reliability attenuators, thermopads, RF diamond resistive products, coaxial terminations, high and low power flange terminations, chip resistors and terminations, and cable assemblies, and many other products from the various brands we represent in Smith. We continue to design for higher power, higher frequency, smaller size, and more cost-effective products for our customer needs. And our yearly product platform launches and product roadmap heavily support the market in this area. So our products and capabilities, from our design facilities to our manufacturing facilities, we continue to offer exceptional passive products and new and innovative products to support our customer needs. As we've mentioned on previous slides, the products below are focused on many different markets in the space and defense applications and other markets. One thing that makes us unique, whether we are building a COTS product or a high reliability product, our process controls are the same and built on the same manufacturing lines. This assures us the ability of conformance with AS 9100 to maintain total quality of our products, whether COTS or high reliability. The design engineering team, along with product line management, specifically designs RF components for demanding high reliability applications. We've developed a core group of products and processes with thin and thick film technologies that are used to develop a broad range of frequency spectrums used in many markets. Along with board level components, we also make several series of cable assemblies, harnesses, supporting critical operations. We have the ability to ramp up manufacturing quickly for high volume requirements to support the customer's new space demanding needs and schedules. We offer S parameters and models for easy design in. We've partnered with Monolithics to deliver models and independent S parameters for our customers who purchase their design libraries. So, our RF products include many different products here. We continue to grow our Space Next series of products consisting of qualified products that can be offered with or without additional testing. Multiple products in this series pre-qualified for space in various frequency bands and product series. The thermopads and fixed attenuators in the same footprint give the designers ultimate flexibility in design choice, offering products from DC to 50 gigahertz. The thermopad series of products is offered in multiple mounting configuration options, as are most of our products. Attenuators range from low-cost options to fully screened flight products. Different products, applications from surface mount to high-power flange style. Our diamond components offer the ultimate power to size rating with reduced footprints to save space in all applications. These products have power ratings up to 300 watts with a wide frequency range. Our resistors and terminations series use robust materials and manufacturing processes to produce economical solutions with short lead times for program and scheduling needs. So that kind of concludes our presentation here, and I'll kick it back over to Katie to ask any questions.
All right, Dave and Tim, thank you so much for the great presentation. So as you just mentioned, we are going to take some questions now. For all of our attendees, if you have a question today, go ahead and place it into the Q&A window and click submit. We will do our best to get through as many questions as we can. Also, just a note, that underneath your Q&A window that you'll be using to ask your questions right now, there is a resource widget. That resource widget does have some items that you can take with you today, so please take a moment to grab those before the webinar ends. So gentlemen, our first question for today, this person is asking, what are the most common surface finishes of the components intended for space and military markets?
I can take
Tim,
that,
you want to
Dave.
grab that one? Okay.
Sure. Gold and tin letter are the most common ones for our space and defense applications. Pure tin or any alloys containing greater than approximately 96% tin is not suitable for space or most defense programs. This is due to tin whiskering, which has caused satellites to fail and other reliability concerns in the industry.
Yeah, thanks, Tim. And also on the finishes too, just to add, we see in the different satellite markets, GEO and MEO traditionally started out using a lot of the gold finishes for wire bondability. We now see a lot of customers switching over to SMT or tin lead products for cost reductions in their satellite programs.
All right, gentlemen, thank you both. So next question here. This person is asking, what are the most common tests and reliability our customers are requesting?
So on the test, you want to grab that, Tim?
No, go ahead, Dave.
Okay. So traditional long-standing customers continue to order HR series type products, as Tim explained in our product series. We do have customers that have extreme reliability conditions, and they choose the HM product line. These are the most regularly we see coming through for quote. We're now seeing, and we've created product lines for newer space markets, which, as Tim explained, the HC testing, and a new to be released product here in a couple months, which is the SPL product line for basically a COTS Plus product. And we've also seen customers, excuse me, in the LEO market using COTS products. So it really depends on the customer and the program as to what comes in. But we are doing a variety of all different types of qualifications.
All right, thank you so much for that answer. All right, our next one here. Can Smiths retain lot quality samples, or do our customers have to maintain them?
I can take that one, Dave. The majority of our customers do take the lot qualification samples themselves, but we do have some customers that do not want the lot qualification samples because they're concerned they may get mixed in inventory, and lot qualification samples are considered destructive, so they don't want to have destructive samples mixed in with their flight units. So Smiths can maintain them. Typically, the retention period is identified either on the contract or on the specification, but that is something Smiths does offer.
Okay, thank you so much for that answer. Just a note for our attendees, if you have a question today, go ahead and place it into that window and click Submit. We will do our best to get through as many as we can. And a reminder to grab those resources before you leave today. I also wanted to mention that we have a survey that will pop on your screen at the end of the webinar. If you'd like to fill out your survey now, you can go ahead and click on that. It is listed in the widgets below the presentation window, so feel free to fill out that survey. Your feedback is always important to us. All right, our next one here, gentlemen. Why is high power actuators are only the standard actuation values starting from 3 dB, 6 dB, and so on?
So I think there's a little bit of confusion in our high power attenuators. We do offer a range of products, usually from 1 to 20 dB. Depending on the product series and the popularity of that, maybe all values aren't available, but depending on the application, and we have a design crew in-house that can quickly turn products with different attenuation values. Most of our standard low power lines have the series filled. The high power lines, we can quickly adapt to a new attenuation value. The problem being is we must fully qualify that product before we sell it as a commercial product. So I guess it's a twofold answer there. Yes, we have the capability to do any attenuation value from 0 dB up to 20 dB. And it depends on the customer application and the quantity needed for us to go ahead and do that.
All right, thank you so much for that answer. So all of our attendees, please enter your questions into that Q&A window and click submit. We are going to take one more question today, and then we are going to wrap the webinar up. So if anybody has any last-minute questions, please enter it in there, and we will get back to you following today's webinar. So gentlemen, the last question for today, what are the passive RF board level components mainly used in space and defense?
So we see a high quantity. The most products we do are in attenuators, whether fixed or temperature variable. The thermopad has a unique quality of maintaining control of signal gain over temperature, and being a passive component, it gives the customer an excellent fit in MTBF rate. So we see most of the products going, RF passive products going into space as attenuators, whether fixed or temperature variable. We also do a high degree of diamond RF components. These range from terminations to resistors to attenuators. Customers choose these because of the size and power and frequency band they can support. The power ratings on these parts from an say an 02, 04 chip can range up to 20 watts. And what we know, as we talked about in the launch costs and the weights of these satellites, weight makes a difference when you're launching a satellite. So where you can reduce weight and footprint space, we see a lot of products in the diamond category in resistors, terminations, and attenuators flying in space.
All right, thank you so much for that last answer. So as I mentioned, we are going to start to wrap things up right now. So I want to start off by saying a huge thank you to Dave and Tim for giving us such a great presentation and for taking some of our attendees' questions. So gentlemen, thank you both so much for being here.
Thank you very much, and we appreciate the time you took out of your day to attend our webinar.
Thank you.
All right, and thank you to all of our audience members for being part of this webinar event. I've mentioned a few times that there are resources listed for you right below the Q&A window in the resource widget. Go ahead and grab those on your way out today. And you will be receiving an email from us with a link to the on-demand version of this presentation. You will be able to come back and watch this again for the next 90 days and share it with colleagues. And lastly, just take a moment to complete that survey, which is going to appear on your screen at the end of this webinar. For on-demand viewers, you're going to find that survey located along the bottom of your attendee console in the survey widget. Again, thank you all for taking time to attend this event. Take care, and we will speak with all of you soon.